Alright. Y'all can see a black screen right now. That's the intended thing you should be seeing, because I kinda lost track of time and I'm still setting up here. But about to happen, I'm about to put music on, and then I'm gonna switch over desktop. So thing that I might want to do is close out of Discord, and that's mainly because I don't want it bothering me. I know streamer mode exists, but it decided to turn itself off on me. I don't know how to turn it back on. Sort of closing screen. Then we go ahead and over laptop. So yeah, basically what happened is I thought it was still noon, and it is not still noon. So that's great. It is in fact way past 1:30, and I announced the stream for 1:30 Eastern Daylight Time. But that's okay. Oh. Goody, the Monstercat site changed its layout. That's good to know. How do I use it? Monstercat, how do I use you? I'm trying to figure out our music problem right now. There's gotta be background music. Give me a moment here. 4 terabyte drive. Our music. There's the programming background music. Okay, great. Why are you giving me a UAC prompt? Windows? Why am I not allowed to right-click on this folder? That's funny. My internet security settings have blocked me from right-clicking on music on my network drive. Windows. It's a great operating system. I know you guys can't see this, but I am actually freaking out right now. So what we'll do is we'll download those files from the network drive to my NVMe, and we'll play them from there. It'll probably run a lot better doing it that way. I'm consuming because it's taking 4 years to create a folder, but seriously, I want you guys. Let's see if I can do this with the Stream Deck here. This is what I'm dealing with right now. Just waiting for this to create a folder. Should not be that slow. I'm gonna copy that over. Do the thing. Alright, back to the blackness, you guys go. Alright. Now I can right click on it. So, play the music, Windows. I'd like to play the music, not move the music. Why is it allowing me to set it as my desktop background? This is disorganized. Open. And it's playing with groove music. Screw it! Alright. Alright. Here's the issue that I'm dealing with here. I cannot actually... I don't know how to use the Monstercat website now to play music. They changed the layout. And I'm trying to play the music locally from my drive, and Windows 11 is being Windows 11. And now I'm just suffering. So we'll do this without music. Sorry, guys. I have to apologize for that. So I'm gonna bring us over to the desktop here. Okay. So now is when the stream officially starts. Okay? And I'm gonna try not to accidentally hit the middle click button on my mouse because that's gonna play Mirror's Edge Catalyst music. I don't want that. That is not ideal. Anyway, thing I will quickly do before we start this. I'm gonna turn on kind of bit hot in here. Alright, there we go. Fan is now on. I'm trying to switch away from the air conditioner because it's September and air conditioners are expensive. Anyway, so welcome to the stream, guys. I'm gonna do one more thing here, and actually I am going to put you guys back into black screen. I'm going to announce this on both Little Big Planet Union and on Trixel Creative because I want those guys over here too. So actually I do need Discord open. Actually I can do it from my laptop. Hang on. Okay. Man, this is organized. You know, it wouldn't be my stream if there weren't technical difficulties, or me forgetting what time it is, or me scrambling to get things ready. It just wouldn't be one of my dev streams that weren't. So on my laptop here, we're gonna go ahead. Discord, which by the way, if you're not there already, you should join, but since I've only announced it on that Discord server, most likely all of you are there. That's great. Anyway, I think I should always schedule these streams for half an hour in advance. I want to start them. That way, there's time for this. Or what I should do is I should start this. Come on. Anyway. Place I'm gonna post this. There's Trixel Creative. Done. And now to LBP Union we go. Takes me a little bit to navigate. Especially since I'm on a touchpad. And there's LBP Union. Awesome. And I'm back focused on the stream chat. And now we get to start this thing officially. Okay. The annoying part is done. Alright, so this is a development stream, but it's also an announcement stream. So before I actually start coding, there are some things that I want to announce right now. I was originally going to do this as a standalone video, but I'll be honest, it's just easier for me if I do it as a stream, as part of the stream. Welcome, Sawyer, to the... Hope I pronounced your name correctly, because that's how my text-to-speech voice pronounces it, and that's the only time I've ever heard it pronounced out loud, so please let me know if I got it right, or how to properly... Okay, so before we start coding, I'm gonna say that this stream is a Thundershock stream. That's probably obvious from the title. Getting distracted by random noise. This is a Thundershock dev stream, so although I have Restitched linked in the description below, I am not developing Restitched. That is a very big no-no. So we're not going to be doing that in this stream, and I don't think I'll ever be doing that. However, there is a reason I have Restitched by Trixel Creative linked in the description below, and that's because I'm actually a developer of the game now, and that is great. So that is... I'll be honest, that was a bit of an awkward way to announce that, but I am really, really, really proud of the fact that I am working with Trixel Creative now. been an incredibly rewarding, incredibly amazing experience to be working with Trixel on Restitched. And I'm definitely learning a lot about code and a lot about collaborating in a team. There's definitely a lot of work I have to do in terms of socially distant and getting that set up to be, you know, even remotely close to Restitched in terms of being easy to develop. And that's where this stream sort of came from. The Socially Distant is a game that I'm working on, my own game, but it's not affiliated with Trixel. You guys might know that already if you've been following the channel, is that I'm working on, along with Restitched, I'm working on a game called Socially Distant, and I'm working on a game engine called Thundershock Engine that Socially Distant is built on top of. And now I'm developing Restitched as well. So I'm starting to become incredibly busy. So ideally, I would like to make it so that Socially Distant is a team effort and not just working on it. And one of the big problems with that is nobody really knows how to use Thundershock unless they're me. I wrote it. So what I want to do going forward is I want to develop some sample projects for the engine that you can delve into and play around with and see how the engine works and how you do things in the engine. That's what we're going to be doing in this stream. I'm going to be developing one of those sample projects. It's going to be Pong. And what we're going to do is, I was originally going to base it off the Pong that's inside ShiftOS, but I decided not to. I'm going to be doing more of a traditional style of Pong that most people would know. But the idea is that we're going to show off both the user interface system and the scene system and just how to build a Thundershock application by building Pong. And then this will go up on GitHub. So yeah, I've already taken care of setting up Thundershock to be usable in this stream because I was originally going to do this as a tutorial, but I thought, hey, let's do a live stream of it, and it's going to be a lot better, and I can spend a lot more time explaining things. I can answer questions live as they come up. And of course, you guys get to hear my dog barking in the background. That's great. All because some neighbor out there has decided, ooh, let's steal a shopping cart from the local Walmart and bring it several blocks away to my great. Yeah, because that happens in my neighborhood. Anyway, right, I can actually. Yeah, that's what I realized, Tobias. I was just reading your message on how only the two of you might actually know what ShiftOS Pong was like. That's why I decided to change the whole idea of this being ShiftOS Pong, because nobody knows what ShiftOS Pong was, and I don't feel like explaining it. So I'm going to be doing more of a traditional Pong. Essentially, what ShiftOS Pong was is take Pong and you add levels to it, which is weird. I've decided to not do that in this project. So yeah. Anyway. So the big announcements going forward, as of course I've already mentioned that Trixel Creative thing and me working with Restitched, which is amazing. And I've already mentioned that I'm going to be doing these live streams to develop these sample projects for Thundershock. The last thing that I'm going to announce before I start this off officially is I'm going to be reinstating the Alkaline Thunder community forum. I took it down because nobody really used it, and I understand why nobody really used it. We have a Discord server. However, I think going forward, a good plan is to use the Discord server for casual conversations like we already do. There's a Little Big Planet or Little Big Planet chat in there. There's a Socially Distant chat. I'm debating adding a Restitched chat, but then again, there's Trixel Creative for that. there might be a Thundershock chat coming. But I also want there to be a place for more formal discussion and updates on my own projects. That's what I want to use the forum for. So I'm going to be setting that up probably later tonight, and I'll let you guys know how that goes and what it's going to look like, probably in a video announcing it. So yeah, there's going to be a community forum set back up again. And I don't know what it's going to look like just yet, but I want to let you guys know that that's something I'm going to be looking into. Anyway, so it has been quite a lot of time since I started the stream, so we're going to actually start this officially. No more announcements. Let's write some code. So, probably see that I have the basic bare bones C# console app here, and that's great. By the way, if anyone knows how to presentation mode, please let me know. I don't know how. I think there might be a way to do it under view. I just want to make it so that you guys can actually see what I'm doing, and I can see what I'm doing. I also have to be careful about what menus I go into, because some of them might reveal Restitched. Probably only under File, though. Appearance. I'm guessing presentation mode would... Yep, there it is. Enter presentation mode. And there it goes. Alright, that's presentation mode. Okay. So we're gonna go ahead and zoom this in. So yeah. We have the bog standard C++, C# Hello World program here, and the only difference between this and other console apps is we actually have access to Thundershock now. So I'm going to walk you guys through the entire process of going from Hello World to Hello Thundershock. If we run this right now, don't take me out of... This is fine. I can handle this. Alright, so what we're going to do is we're going to actually go ahead and move this little panel here down, because you guys don't really need to see it, but yeah, so this is going to be my little view here. So code at the top, and then a little tiny console. We have access to Thundershock, so I'm going to walk you guys through the entire Hello World process of Thundershock. The boilerplate code, so to speak. So, the first thing that we need to do, create an app. I know that sounds very condescending, but that actually does mean something in code. So, the way Thundershock works is you have different types of apps you can make in it. You have a command line app, which is a console app, but it has access to Thundershock's runtime. You have a graphical app, which is basically the base for all games. Except not really. The graphical app base allows you to fully control how Thundershock boots up. And then from there we have a new game app base, which takes care of the game-specific stuff for a graphical app. So that's what we want to create for a Pong game. We want to create some sort of graphical game application. So to do that, we're going to create a sealed class here called Pong app, and we're going to inherit from new game app base. Now the reason it's called new game app base is actually because this used to be a mono game framework thingy, and now it's not, and I just haven't bothered to rename the class. So eventually that will be game app base, or probably just game app. But anyway, we're gonna take this code here, and I was gonna move it into its own class, but instead what I'm gonna do is I'm gonna set up the entry point. So our program main function here needs to actually tell Thundershock what we want to do with it. And we do that with the entry point run method. So entry point.run. And it takes in one type parameter, which is what these angle brackets mean if you don't know C#. And this type parameter is the type of app you want to run. So in this case, we've created a Pong app, which is a new game app base, and we obviously want to run the Pong app. So we're going to put the Pong app in. And then we also need to specify command line arguments, because Thundershock has some special command line arguments that you can use that I'll go into in another video. And we don't care about those command line arguments in this stream, so we're not going to worry about them. But if we run the code now, this is enough to get the game running. And as you can see, instead of a hello world prompt in the console below, we have a window, and that's great. And you guys can even see the window. And in fact, if I press the tilde key, we get a developer console, which is proof that Thundershock is loading. That's great. Now, of course, apps are great. They let you spawn windows, but that's pretty much all they let you do. So in order to create a game, we actually need a scene. This is a very common thing in most game engines. In Unity, you have scenes. In Unreal, you have levels, maps, or whatever you want to call them. In Thundershock, we have scenes. And scenes are just like apps. They are classes. So we're going to create a sealed app, or sealed class, Pong scene. And from here, inside of our app, we're going to do a protected override on load. And this allows us to run code when Thundershock is actually finished initializing and is ready for us to start running game code. And the first line of game code that we're going to run is, we're going to tell it to load our Pong scene. And that's basically all we need to do in terms of our Pong app here. So we're going to go ahead and move this to its own file. We're done with it. We don't need to worry about it. So move to pongapp.cs. And then from here, we're actually going to move our Pong scene into its own file. And this is where we're going to spend a lot of our time inside of this scene class. So, I'm going to take a moment to read that here. Give me a moment. I'm blind and yes, the forum will be Discord. My main site is powered by Drupal, and Drupal does have a built-in forum, but it's not for what I want to use it for. So yes, I will be using Discord. Most likely. Wait, I actually did task view on my laptop. I will likely, I don't know if I'm going to integrate. But I don't know if you can integrate. But I'll figure that out. I will likely integrate it with Discord as honest. Mono. Screen's mono is the default. I don't change the default settings. And why a sealed class? No reason. Preference. I mean, I don't intend on letting you, or I don't intend on inheriting from Pong scene or Pong app, so sealed kind of enforces that. So it's kind of just a practice I have. I do the same thing in Socially Distant most of the time. If I don't intend on inheriting from it, why let you inherit from it? So that's a weird quirk of mine. Anyway, inside Pong scene, we're going to write some more onload code, and this code is going to run when the scene first loads, and this is where we're going to set up our game. So we're going to do protected override onload, and let's just do something extremely basic with Thundershock here. And that is set the background of the window, and we can do that with primary camera settings, .sky color. I'm calling it sky color because I kind of intend this to be a simple 2D engine, and the background is obviously going to be the sky. So, in terms of the sky color, I'm going to set it to color, in Thundershock.core from HTML, and we're going to do the basic piece color, which is 1BAAF7. See, that's something that you can do in Thundershock that you can't really do in other C# frameworks. Maybe you can. Actually, you can with system.drawing. I don't know about WPF. I know monogame you can't. You can actually just straight up define an HTML color and it'll work. But anyway, we run the game, this is what should happen. So you can see that our window is now blue, and that tells us that our scene is loaded, and that's great. So we have a nice blue sky. Now, of course, I don't want it to be blue. Blue is very bright, it's hard on my eyes. And I want my Pong game to be a dark theme. In fact, looking at that blue was enough to actually set off my eyes and make me go blind for a sec, so that's great. I'm gonna make this be that color, which is a very darkish gray, which is what I prefer to use as my dark color, instead of just straight up black. That's great, we can do that. So we're gonna leave that as is. Another thing that we might want to do is, by default, the primary camera is set to orthographic, because again, this is a 2D engine, and most 2D games are orthographic. If you want to do parallax, you might use a perspective camera, but by default it is orthographic, and we want orthographic protection for a Pong game. We don't need parallax, we don't need any sense of depth. So, even though the default setting is to have it be orthographic, I'd rather set it explicitly, just in case the default does change. So to change the perspective mode, we just, set it in the primary camera settings. So projection mode equals projection mode. Whoops. I actually forget what it is. Nope, it is very clearly not that. What is going on with it? It is camera protection type, but for some reason Ryder didn't add the namespace, so it went red on me. Great. So I want orthographic here. Okay. So that's just setting a default setting and ensuring that that is the setting that we're going to use. The next thing that we can do is set some sort of game width and game height. Which is different from the window width and the window height. And the reason we want to do that is likely this game is going to run at different resolutions. For example, on my system, I have an ultra-wide monitor. It's a 21:9 aspect ratio monitor that runs at 3440 by 1440. But right now I'm running in 2560 by 1440 for the stream. And one really annoying issue when you're doing game development is trying to figure this whole thing out, trying to prepare for the different types of aspect ratios people will run at. So what we're going to do is set that whole thing up, make sure that the game runs in some sort of known resolution, even regardless of what the aspect ratio is. I can't actually I do know how to do that. It is the ortho width and the ortho height. So what I'm going to do is I'm going to set the ortho width to 1600. And the ortho height to 900. So that is our base resolution. And the next thing that I'm going to do is I'm going to set the aspect ratio mode to scale vertically. Actually, no, scale horizontally, ignore me. That means that it will always be 900 pixels, or 900 units tall. Oh, you cannot actually change the aspect ratio mode. Okay. I think it's already defaulted to scale horizontally. I think that's something that I did. So that's great. But anyway, that's our camera settings dealt with. So set up the required camera settings. Now, the next thing that we need to do is get a ball on screen. So how do we do that? Well, this is where the ECS comes in, the entity components. The way it works in Thundershock is you have three main types of things that you build your scene up with. You have entities, which are things. That's what they are. They are things. And the components define what those things are. And the systems define what those things do. So the way we do this is we create an entity for a ball, and we assign some components to it that give it a position and give it a sprite so that we can define it as being our ball. And then we're going to write a system, which is really just code that runs every frame, to define what that ball does. That's the way it works. So we're first going to start by defining the components for our ball. And naturally, for a 2D sprite, like a ball, like a paddle, we need two things. We need a transform component that tells us where the ball is in the world, and we need a sprite component so that we can actually render the ball on screen and see it. So we're going to create those two components by doing private transform 2D ball transform equals new. I like the modern versions of C# because you can do implicit constructors. Great. I love implicit constructors. I don't like writing the same thing twice if I can at all avoid it. So that's great. That's going to create us a new transform for the ball. And of course, we need to be able to see the ball, so we're going to create a sprite. Now, I'm actually going to call the sprite ball sprite, and I'm going to call the transform ball, because most of the time what we will be doing is dealing with the transform rather than the sprite. And the transform is basically where the ball is, so that's something to note. Anyway, to get this on screen, we need to do two things. We need to set the ball sprite width and height, which, by the way, I'm going to define that as a constant. Private const float ball size, and we'll go ahead and do, I don't know, 40 pixels, or whoops, 40 units. There we go. And then what we're gonna do is we're gonna say ball sprite.size equals new vector 2. We're gonna specify the ball size twice, which creates a uniform vector of that size. And then, to get the sprite actually in the game world, what we're going to do is we're going to create an entity, so var ball entity equals registry.create. And that's going to return a uint, and that is the ID of the ball. This is the ball entity. Now, it's not a good idea for you to keep track of these. The engine should do that for you, and you really should not be referencing entities directly, unless you're actually creating them and assigning components to them. So that is why this is a local variable and not a global variable, because once you've got the entity set up, you should never be interacting directly with the entity, just its components. So to add components to an entity, we do registry.add component, and we give it the entity ID, so ball entity, and we give it the component that we want to add, so _ball for the transform. And then we duplicate this, and we're going to add the ball sprite. So this code here sets the ball size, and this code spawns the ball entity. And if we run the game, you can see that there is now a square in the middle of the screen that is our ball. And in fact, if I try to, I don't know if I can, but let's try resizing the game window. You can see that it is actually trying its best to keep the... Oh, it's not. I stand corrected. Alright, Could have been resizing the camera too frustrating, but that might be a bug in the engine. Great, I found a bug! I'll have to fix that. I can't believe I'm saying this, but I'll have to restitch Thundershock. Great. That's great. Anyway, that's great. Actually, I shouldn't be able to resize a game window. Also a bug. Anyway. Take a moment to read that. Ball entity.add component. Yeah, that is. I experimented with encapsulating entities inside of objects. There is an API that lets you do that. It's actually, I believe it is var test equals spawn. Yeah, spawn object, and that'll give you a scene object that you can then do add component on, but you're not really supposed to keep references to these at all. So I've decided to just not do that. There's no point in using this API. It just kind of existed because I wanted to see how it worked, but really it's a lot easier to go ahead and just... I mean, when you write a system, you're going to be using the registry API either way, so it really doesn't matter. As long as the entity is set up on screen and you don't hold a reference to it, it's fine. Why did it... Oh, wait. I accidentally got rid of the comment. But yeah, that is why... So actually there is an API that lets you do it in an object-oriented way, but the thing you need to understand is ECS and OOP are completely different paradigms. And so, why would you want to adapt ECS paradigm and an ECS way of doing things to OOP? They're completely different programming paradigms. So yeah, that is effectively what we're doing, is we're curb stomping OOP doing this, and that's doesn't really matter. We're not really using the full potential of the ECS in Pong, but we still need to use it to get the ball on screen, so yeah, anyway. Let's actually get the ball moving. Get the ball rolling. So to do that, we can actually use the onUpdate method of our scene. And this is kind of not a scalable way of doing it. Ideally, what you would do is you would register a system. Socially Distant does this a lot, so it has a networking system. It has a mail delivery system. It has a notification system. It has a shell system, and they're all different modules of the game that work with entities in different ways. And that's really where the power of the ECS shines. But for something like Pong, we can get away with using the onUpdate method of the scene to do what we need to do, because we only have one ball entity and we only have two paddle entities. Anyway, let's focus on getting the ball moving. Now, there are many ways we can do ball movement. We can have a direction and a speed. That's all well and good. We can have two quote-unquote speed values that are units per second, and we multiply them by the game time, or we can simply have a unit per frame value for the X and the Y directions. That's the last way I just described is the way that ShiftOS did it, and it's the way that I want to do it. Now, it's not the best way to do it, but it's a quick and dirty way to do it, so it's going to work. So the way we're going to set this up is we're going to define two float values. Ball X speed and ball Y speed. And I'm going to set them both to 3. And the reason they are floats is because I would like to introduce fractional values to them. But anyway, the way this works is we get the ball position, so var ball pose equals ball position. And then we do ball pose, we add a new vector 2 to it, ball x speed, ball y speed. And then we say ball position equals ball pose. Now I could condense that down to one line of code, but I don't feel like it. Anyway, we're going to run this and see how it works. As you can see, it's running at thousands of frames per second, so the ball moves incredibly quickly. We can fix that by multiplying it by the delta time. And to do that, it is multiplied by float game time, elapsed time, total seconds. Just like you would in monogame. Except this isn't monogame. I mean, come on, there are some APIs in monogame, actually, and that's one of them. But anyway, our ball is now moving incredibly slowly, but it's moving at a constant speed, regardless of the frame rate, which is actually 75 hertz, or 75 FPS, because I have a 75 hertz monitor, and I have VSync turned on. But, what we can actually do is go into Windows Terminal here, and what I'm going to remember what I named the project. I'm going to assume nope, there is no Thundershock samples. There's only Pong, Pong, and we're going to do a nano config, and we can actually turn VSync off, and that's going to allow us to see what the game runs like at a maximum frame rate. At the maximum potential of your graphics card, based on what Thundershock can do. As you can see, VSync is... oh, VSync is off. Yep, it is off. We are running at almost 2000 FPS. Over 2000 FPS sometimes. And the ball is still moving at a fixed rate, so that's good. And it's actually very important that we do that because, of course, Thundershock games generally do hit 1000 frames per second when VSync is turned off. So if I were to comment out this line of code here, or this part of the code here where we are actually multiplying it, what I'm just going to do, if I comment that out, see how fast the ball moves now. Literally unplayable. I saw it for like 2 frames. Anyway, that's not exactly great, so it's good that we have this working. So we're gonna make sure that that is working again, and actually I'm going to increase the speed of the ball to 12. And as you can see, that's a pretty... it's still pretty slow. So let's increase it to, or let's double it, 24. And that's a bit better. Okay, so now let's get the ball moving, or let's get the ball bouncing off the screen. So this is very complicated. See, what we need to do, we need to take the ball's position, and get it out of world space, and into screen space, so that we can then check if the ball is off screen or not. So I'm going to actually write a method to do that. Now, eventually this method will be inside of Thundershock's core framework. What we're going to do is we're going to do a public static rectangle, and I'm writing it as static because I intend to move it into the engine's core framework. Get screen space bounds, and we're going to take in a transform 2D transform and a sprite. And what we're going to do is, based on the sprite size and the scale and all that information, we're going to get the screen space bounds. Now I'm going to expand this function later on once it's integrated into the engine. We don't have a scale we need to worry about. But we are actually going to worry about it. So var size equals sprite.size times transform.scale. Now the next thing that we need to do is get the screen bounds. And screen bounds is going to be new rectangle. It's going to be 0, 0, primary camera. What? Oh yeah, this is a static method, so I can't access them. Okay, that's great. Primary camera settings.ortho width. Ortho height. And actually that's the view bounds, so that's great, that's fine. The view bounds is that rectangle, and what we're going to do is we're going to subtract the position of the transform from the center, or no, yeah, from the center of the view bounds. So that's going to get it out of world space and into view space. So var position equals transform.position. And while we're at it, we're going to actually subtract the size divided by 2. Alright. And then position is going to be subtracted. We're going to add the center. I'm dumb. So position plus equals view bounds dot center. Now we need the screen bounds. And screen bounds is easy. It's viewport bounds. And then position is going to be multiplied by I believe it's going to be view bounds dot size over no wait, yeah, I'm trying to think how I'm going to do this properly. Yeah, it's probably view bounds dot size divided by screen bounds dot size. Alright, so that gets us our screen space position, and then we're going to return a new rectangle. Position.x, position.y. Oh yeah, I also need to multiply size by that. Size.x, size.y. That's a method that's going to get our screen space position of a 2D object. So var volrect equals get screen space rectangle and screen space bounds, and we're going to give it the ball and the ball sprite. And then what we can do from here is we can also grab the screen bounds. Equals viewport bounds. And actually I'm gonna move this code above where we update the ball position. And basically, what we're going to do is we're going to say, okay, if the ball rect bottom is greater than or equal to the screen bounds, bottom. Then we're going to invert the ball speed, y-axis. We're also going to do the same thing if the ball's top coordinate is above or is less than or equal to the top of the screen. We should see that in action. You can see the ball should no longer go off screen until it hits the left and right side of the screen, which is going to be a different behavior altogether. So as you can see, the ball is now moving and it's going to inch toward the bottom of the screen here, and as you can see, there we go, it moved. So it bounced off the bottom of the screen, and that's great. And then as you can see, it's about to hit the other side there, and it's going to not bounce off. Now, from here we can actually program game logic for the score. So we're going to have two score values, and we're going to have a player score and a CPU score. So private int CPU score equals 0, and private int player score equals 0. And what we can do is we can check the ball's left position, and if it's outside of, or it's beyond the right bounds of the screen, then we can give the CPU or the player a point because it got the ball past the CPU paddle. And if the ball's right coordinate is less than or equal to the screen's left coordinate, then we can give the CPU a point because it got it past the player's paddle. So let's set that up right now. If ballrect.left is greater than or equal to screenbounds.right, we're going to go ahead and first of all, we're going to invert the x speed. We're going to give the player a point. We are going to give we're going to make the ball spawn in the left or in the right quadrant of the screen, which is sort of annoying to do. But for now, what we can actually do is just we can just say, okay, we're going to set the ball position to vector 2.0. Alright. That's our player score, or our player score logic, and if we duplicate this code, we can set it up to check the right coordinate of the ball to be less than the screen coordinate, or screen left side, and then in that case, we can give the CPU a score, or CPU a point. Okay. So that is our score logic set up. Let's give it a try. We're going to let the ball bounce off the bottom and let it hit the side of the screen, and we should give ourselves a point. Of course, we can't see it give us a point, but we can see the ball respawn. And it's about to do it, and there it goes. So now it's going to move toward the other side, and now we can test the top side of the screen to see if it works. It is really slow. And the CPU gets a point. Okay, so that all works. let's actually add some paddles. So we know how to spawn an entity in. Pretty simple. We have to create a sprite and a transform. So we're going to create the CPU transform. We're going to create the player transform. And I made these 3D transforms. I wanted to make them 2D transforms. I'm dumb. If you try to assign a 3D transform to a 2D object with a sprite, the engine will not render it. Just a heads up. And anyway, we want the player to have a sprite, so private sprite player sprite, and private sprite CPU sprite. Okay, and then we need to define some widths and heights for these sprites, so private private const float paddle width. And I want it to be a bit skinnier than the ball, and I want it to be a lot taller than the ball. Alright, so let's set these paddles up. Of course, we need to set paddle sizes. And we need to set the player height as well. And then we need to spawn in the entities. Spawn in the paddles. CPU entity equals registry.create. And then registry.add component. CPU entity. CPU. Registry.add component. CPU entity. CPU sprite, and then we can duplicate this code for the player. Okay. And I'm also going to do a little bit of sorting of this code here just to reorganize it. So we're going to create the variables first, and then I'm going to make sure that I assign the transforms first or second, and then I can assign the sprites after. Okay, so now we have paddles on the screen, and that's great. Paddles on the screen is a very good thing. But as you can see, they are stuck in the middle of the screen. Apparently, one of them. We need to position them somehow, and this is where things get very annoying very fast. We're going to create another method here, private rectangle get view bounds. And this is simply going to be exactly this code here, where we get the view bounds. And instead of storing it in a variable, we're going to return it. And in the interest of not having code duplication, we're going to use that method now. Quick little refactor, and there we go. So how do we position these paddles properly? Well, it's fairly simple. We know the viewport bounds now, so we can get those. So we have the viewport, or we have the view bounds. That's great. When Thundershock 0, in a 2D game is the center of the screen. I know it might not be very intuitive for people working in monogame, where 0 is actually the top left, but for people working in other game engines, it is intuitive because 0 is the center of the world. It is the origin point. And what we effectively need to do is we need to set these paddle positions relative to the origin point instead of the top left of the screen. That's where things get a little bit confusing in Thundershock. So this is why we need the view bounds, because the view bounds gives us the screen, or the view size, so how big our camera frustum is. It also gives us where on the camera the center of the screen is, or the center of the world is. So viewbounds.center is where in camera space the origin of the world is. Sort of. If the camera is in a different position, then this is not the same. But when the camera is sitting in its default location, this is the origin point of the world. So basically, what this also means is that's also half of the screen size, or half of the view size. Very, very useful. See, the way we can actually do here is, just for an example, CPU.position, if we just set that to a new vector 2, where the x position is the view bounds center x position and the y position is 0, what do you think is going to happen? We're going to find out. It's on the side of the screen there, and that's great. Except it's a little bit cut off, because we need to actually add some padding, and we can do that with a constant variable times a const float paddle padding, and I'm going to set that to 100. So if we subtract 100 from the center position, that'll pad it to the right, or to the left, by 100 units. And there we go. That's a pretty good spot for the CPU paddle. Likewise, we can do the same thing for the player position, except that we invert some things. Traditionally in Pong, the player is on the left side of the screen instead of the right side of the screen, so we're going to add a negative in front of the viewport bounds.center.x. And because we don't want it to pad to the left, we want it to pad it to the right, we're going to add the padding. And there we go. We have a pretty good looking Pong game so far, but of course we can't control these paddles. They don't have any logic associated with them, they don't have input, they don't have collision, there isn't a CPU running things yet. Well, there is. My DM is running the game, but there's no CPU controlling the paddle. So we need to set all that up for this to be a complete Pong game. So let's do that. The player is pretty easy to set up. We can use the input system. So in Thundershock, input systems, or the input system is very raw in how it works. So instead of something like Unity, where you would go in and set up different keybinds and axis mappings and stuff like that, I do plan to add that, by the way, later on next year. The Thundershock input system is very direct. If you want to get a mouse movement, you literally just subscribe to a mouse move event, and you will get a mouse movement. So we're going to do that. We are going to subscribe to the mouse move event, and we're going to add an event handler. That basically uses the delta value of the mouse. Now, we're going to get the view bounds. Right? We're going to get the screen bounds. And what we're going to do is we're going to take the y coordinate of the mouse, and we're going to divide that by the screen bounds height. And then we're going to multiply it by the view bounds and its height. And then we're going to subtract the view bounds center y coordinate from it. So that's going to get the mouse's position in terms of the world space, which is what we want. Then we're going to set the player's y position based on that. That's player movement done. Would be cool to have something like Unity's relatively new input system. I agree. It's just I haven't gotten that far in the engine, but as you can see, the paddle is now moving in relation to where my mouse cursor is, which is, you know, the way you would like to control Pong. If you move your mouse up, the paddle goes up. Now, there is a slight problem. Let's demonstrate that problem very soon. Ball moves toward the paddle. So it's looking like it's about to hit us. As you can see, it passed right through the paddle. That's not great. So now we need to implement collision logic for the paddle. We know how to do that. We know how to get the bounds of the paddle, and we have the bounds of the balls, so let's get the bounds of both paddles and implement them in one shot. So var player rect equals get screen space bounds for the, and as you can see, this is where the power of the ECS comes in, because we have a system for getting the bounds. We have the transform for the paddle, we have the sprite for the paddle. It's all just data, so as long as we pass the right data in, we're going to get the right data out. That's great. I love this. So we're going to pass in player for the transform and player sprite for the sprite. And then for the CPU, we just replace the word player with CPU, and it's going to get us the same data. So now what we can do is we can say, okay, does the ball intersect with the player sprite? And if it does, here's what we're going to do. We are going to get the, or we're going to take the ball and we're going to set the position to be, so var bpose equals ball the position. And we're going to take that position and we're going to actually get the p-pose. Okay, and then what we're going to do is we're going to take p-pose and set it to be p-pose. Except we're not done yet. We need to actually pad the ball a little bit. We need to add half the size of the ball and half the size of the player. I will make this a lot more clean, don't worry. Okay, so that offsets it. Now we do have another problem. We are actually setting both the coordinates and we don't want to. We just want to set the x coordinate and leave the y coordinate as is. And then what we can do is we can set the ball x speed to be math absolute ball x speed. That ensures that the ball x speed is moving away from the player rather than towards it. Then when we add the CPU, we're going to negate that absolute value and it's toward the player again. So let's try that out in practice here. So we're going to duplicate that code, and we're going to say, okay, if the ball is intersecting with the CPU rect, then we're going to do things a little differently. And then in this case, we don't want to add these values, we want to actually subtract them, and we're going to subtract the CPU sprite width as well, instead of the player. And then we're going to negate this, and I realized that I messed up another thing. I forgot to set the position of the ball to T-pose. So quickly fix that in both these if statements. And we have a good Pong collision going on. Speed up the ball to triple what it is now. Yep, I'm agreeing with you on that one. Let's do it. 24 times 3. What the hell is that? I have no idea. 24, 48, and then 72. I think. And we'll give 72 a try anyway. That's much better. Okay. Thank you, Tobias, for that for that idea. That was definitely needed. Anyway, let's see if it works. Bounce the ball off us. And we can. Now let's see if it bounces off the CPU. Except we can't, because the CPU doesn't actually react to where the ball is. Alright, so let's fix that. Because obviously if the ball is kind of, moving toward the CPU and the CPU doesn't move to hit the ball, Pong is suddenly extremely easy to beat. And, that's not great. So let's fix that. There are many ways you can do a Pong AI. Many ways. There are really crappy ways to do it, and there are really freaking brilliant ways to do it. For the sake of demonstration, I'm gonna do a crappy way of doing it, but I'm not gonna do a totally crappy way of doing it. I'm gonna be fairly crappy. So this AI, the way it's gonna work, is we're gonna first check if the ball is close to the CPU panel, and by that I mean it's on the right-hand side of the screen. When it's on the right-hand side of the screen, we're going to check if the ball is moving toward the CPU. So if it's moving in a positive direction on the x-axis. And only then will the CPU actually react to the ball moving. And what it will do is it will look at where the ball is in the world in terms of vertical space. And it will look where the CPU panel is in world space. And it'll subtract, or it'll get the difference. So then what it'll do is it'll say, okay, if I'm vertically above where the ball is, I'm going to move down toward it at a limited speed. And if I'm below where the ball is, I'm going to move up toward it at that same speed. And when I'm in line with the ball, I'm going to stop moving. So effectively, it tries to hone in on where the ball is going to be. But it's a really crappy AI because it's very accurate. However, if the ball is moving fast enough, it might actually trick the AI. And we can also add other little hacks, like every few frames it misses, or it overcalculates, or it undercalculates, or it just flat out doesn't do anything, to give it some vaguely human qualities to it. But of course, this is a really crappy AI. But still, this isn't about AI. This is about getting the engine to do what we want it to do. So let's figure this whole thing out. So, luckily, what we have is pretty good. So what we can do is we can, of course, grab the CPU position and the ball position, which, of course, we know, because it's an ACS. We have that position value in the world. So where we go and grab the ball pose, what we're going to go ahead and do is also grab the CPU pose. And what we're going to do is, as we move the ball here, what we're going to do is we're going to say, okay, let's subtract the CPU y-coordinate from the ball y-coordinate. And we're going to call that the CPU distance. I think I did that right. So what this should do is it'll be a positive value if the CPU is above the ball, and it'll be a negative value if the CPU is below a ball, or below the ball. And then what we can do is we can go ahead and find a maximum speed for the CPU, just like we did for our ball. So private float CPU speed. And I'm going to set it to something a little bit below what the ball speed is, because I don't want it to be totally on the ball. So what I'm going to do is I'm going to say, okay, this value is going to be clamped by the CPU speed. So var CPU movement equals mathhelper.clamp. Yes, I know that looks like monogame code, but it's actually not. It's actually a much more intelligent clamp that allows you to use any numeric type or any comparable type, which is really handy. Anyway, we're gonna clamp the CPU distance to be between the negative CPU speed and positive CPU. And we're going to multiply that by delta time. Okay, so that is how much we have to increase the CPU position. So we're going to do that. And then we can commit it back into the CPU. However, we did mess up. We actually did not check the first two requirements, but we can see this working in action. So as we start to move, you can see that the CPU is trying to move toward the ball, and it's doing a pretty good job. As you can see, it actually hit it, so that's good. I made sure that that code worked. But as you can see, the CPU is still tracking the ball even though it's on our side of the screen, which isn't exactly human. In fact, you even saw me not move my mouse for the entire time that the ball was not on my side of the screen. So if I'm not doing that, then why the hell is my CPU doing that? What's the point? Well, haven't actually written any code to dictate that behavior. So we're going to do that. The way we do this is, of course, we check the ball pose to see if it's above 0. So if ball pose .x is greater than 0, then it's obviously on the right side of the screen. We're also going to check if the ball speed, or the ball x speed, is above 0. Because that tells us that it's moving toward the AI. As you can see, it's behaving mostly the same, and it stops moving whenever you or whenever it hits the ball off the AI, and that's a good thing. That gives you a chance to actually beat it. As you can see now, it's on the right half of the screen, so the AI is trying to catch up to the ball. It still hits it. Really entertaining Pong game. I mean, it is decent. It does show off how to use Thundershock to build this. Great. Now, there are other ways we could introduce some human qualities to this. We could introduce a max reaction time. So let's do that. Let's actually track the CPU distance, or CPU movement, inside of that variable, so that we can track it across frames. Oh yeah, and we also want to check, or we also want to track a reaction time, so we're going to do that as well. Private double. Last, or time since last reaction equals 0, and private double reaction time. Let's set it to something like 0.1 seconds. So 100 milliseconds, a tenth of a second. So what we're going to do is every frame we're going to update that time. If, or no, game, or no, I'm having a brain fart. Reaction time plus equals to game time dot elapsed time dot total seconds. Also, Tobias in the chat says he didn't realize this looks like monogame. But of course, I did realize it looks like monogame because I've been using monogame for years. Anyway. So we've tracked the reaction time. Let's track the CPU distance. And what we're going to do is we're going to say if reaction time is less, or is more than or equal to max, or reaction, this variable here that I can't read, then we're going to change the CPU movement. And then of course we're going to say reaction time is equal to 0. So that's going to add an inherent limitation to how fast the AI can move, and right now it can move at 0 pixels per second, 0 units per second, because I am dumb and stupid and forgot that little underscore there. Anyway. So now you can see that it is moving fairly smooth, but there is a lag behind. Another thing that I'm going to actually change, or no, I'm not going to change that. Okay, so there are two things that we're going to change here. We're going to increase the ball speed every time the ball is hit by the player and by the CPU. We're going to increase it on the X coordinate. We are also going to increase the ball speed on the Y coordinate. when we hit the top of the screen, or the bottom of the screen. So, private float ball speed x increase is going to be, I'm going to set that to 0.05f. Actually, no, we're going to do 6f. And then private float ball speed y increase, I'm going to do 3f. And then when we hit a paddle, all we have to, or when we hit the top and bottom of the screen, we're going to, okay, so we're going to set, or we're going to increase the y speed. So, what is the best way to do? So if it's less than 0, we're going to decrease it. Or increase... Basically, we're increasing the magnitude, not the actual... Oh my god, my brain hurts. I suck at math, by the way. If that isn't apparent. Alright, so that's going to increase this. Yeah. Weird that it stops after the ball. After the ball down, or after the ball bounces. Yeah, it does. And we can fix that by simply, we can fix that by, tying it to the reaction time. First of all, we're going to move this out, and this out. And then we can tie it to the reaction time. I think that should be enough to do it. Also, I'm going to invert these if statements because I caused a bug. Okay. So this is going to fix that issue. This is going to set the CPU movement to 0 when it starts moving away. And of course we can increase the reaction time to increase the delay at which it stops moving. Let's do something like 0.5. Alright, personally think that that's doing a bit better. It works. That's all I'm gonna say. It works. Alright, so now let's make it so that it actually increases the ball X speed when we hit the paddles. This is the player paddle, so obviously ball X speed is going to be increased. Okay. And then for the CPU, there we go. So now the ball speed is set properly for the paddles when they get hit, and for when we hit the top and bottom of the screen. That allows this game to gradually speed up as we play it, because that's kind of the challenge of Pong, at least when I implement it, is that the game gets gradually faster and thus harder to react to, harder to play. It's kind of a really artificial difficulty increase, but for the sake of demonstration, it works. So yeah, you can probably see that the ball speed gradually. Now, let's add some UI, and then we'll end off the stream. So UI lets us do a lot of things in Thundershock. We can create buttons, we can create text blocks, we can create text entries, we can create developer consoles. But right now we really only need text and maybe some buttons. Ideally what I would like to have happen is I don't want us to be updating, or we need a pause mechanic for the game. When the ball basically does what it's about to right now, falls off the screen, I want it to pause for a few seconds, so it can give you a countdown. I also want it to be paused at the start of the game so that we can explain the controls and how to play and stuff like that. We're going to set that up. So first, let's set up that initial game screen. So let's start by adding a pause variable. Whoops. This is not C++, you cannot do that. Anyway, I set a boolean value to the pure value of z. Alright, well, I'm gonna have to do something really quickly, and I will be right back. My bad, I just got to let live streaming. Anyway, I will do that thing later. Anyway, what were we doing? Oh yes, we were implementing a pause mechanic, and I was saying how I accidentally set a boolean value to 0 instead of false. Can't do that in C#. So we are going to finish that pause mechanic by doing if_pause, then return. It's that simple. And then what we're going to do is we're going to set up some UI. So first I want to do some code organization here. First, I'm going to set up a region called constants. And we're going to move all these constants inside of there. That allows us to collapse the code, because we don't need to look at the constants anymore. Trying to find the region collapse button. I cannot find it. There it is. Okay, I just needed some... No, wait, no, that is not the region collapse button. Okay, Ryder, you're being weird. Okay, maybe it doesn't exist in the presentation mode? That would be weird. That collapsing code doesn't exist in presentation? Oh well. We're going to create a game state section for all of these game state variables. So are we paused? Are we counting down? Are we doing UI stuff? Stuff like that. So we'll take all these variables and copy them into here, or rather move them. There we go. And there we go, and there we go, and there we go. So that's a lot of variables. Holy crap, this grew quickly. Anyway, and then what we're going to do is create a region, start screen UI. And we're going to set up a basic panel. Oh, whoops. Start panel. We're going to create a vertical stacker for start stacker. A text block for the title. Text block for the game instructions, and a button for the start button. Okay, so from the start, for the start screen, here's how we're going to set it up. First, we're going to start by adding the start panel to the viewport, which is going to have this effect. We have a white screen now, and that's not great. We can set the background though, don't worry. The background can be set by setting the back color of the start panel. No, I don't want system.drawing.color. I swear, Ryder, I have my own color structure. You know I have my own color structure. Why are you using system.drawing.color? Oh, please tell me I'm not muted. Hope I'm not. You guys let me know in the chat if I'm muted. I have no idea if I'm muted. Suppose I can also check OBS to see if I'm muted. Or I can look at the LED on my microphone that is very clearly green. That would also work. I forgot about that. Anyway, we are not muted. Okay. I don't want to be using a drawing color. I have my own color structure, and all I want you to do, Ryder, is you see this? You see this color structure that isn't in system.drawing? Use that. Okay? Use that. Thank you, Tobias, for letting me know that I am not muted. I forgot to realize that there was a green LED on that goes red when I'm muted, so there's that. Which is really weird, because you would think that red means it's actually live, and green means... I don't... Anyway. So we've set the background color of our panel here. The next thing that we're going to do is add the stacker to it. So start panel.children.add start stacker. And also what I'm going to do is I'm going to set the start stacker's layout to be centered. There we go. So that allows us to center it on screen, and that's good. And from here, what we're going to do is we're going to add the two text elements and the button element to the stacker. So start stacker.children.add title, game instructions, and button text, or start button. We'll see why I accidentally said button text in start button. It looks as though the panel color did not take effect. That's great, but we have a start button here. This is button text. Why, Thundershock, are you rendering a white panel where there should be a black panel? Set it to black for a reason. Let me investigate this. There might be a reason for it. Okay. Style.paint element background. That's relatively normal, yeah. Okay, there's one override in solution. Why are you just hard coding the color? Why are you getting it from the back color as well? Okay, let's fix that. Element. So first of all, dot back color or style color dot default dot get color BP colors. That's a very fancy way of saying use the user-defined color or the default skin color, which fixes a bug in the engine that I didn't realize was there, because in all of my games I always override the default skin of Thundershock. But anyway, there we go. You can see that we have button text and we have no other text. That's because we need to set the text color as well. So we're gonna do that. This is where the skinning system really needs to be fleshed out, because it's very annoying to get a non-default look. And the default look is very, very ugly intentionally, because it's meant to work, not be good. Anyway, title.color equals color. Oh, it's for color. Now, Ryder, use my color structure, not system.drawing. You dummy. You dumb little IDE. You are a great IDE, but you are a dumb little IDE sometimes. One of those times. Alright. So, game instructions dot for color. There we go. I still don't. Oh wait, yes I do see text. Never mind. It's all. Anyway, let's add to this. So what I'm going to do is I'm going to set a fixed width on the start stacker. So that's going to allow the button to take up a large amount of space. Fixed width is sort of a thing you have to be careful with, because if you're not careful with fixed sizes in the Thundershock engine, what will happen is at low resolutions, we'll experience by cutting off. It does try its best to scale the UI based on the aspect ratio and the resolution, that the text is readable and things generally take up the same amount of space, but it is not perfect, and you have to be very careful with it. And fixed width is one of the times where you need to be very careful with it, but for Pong, it's gonna be fine. We're just gonna set it to 480. Start stacker, not start panel. Alright, so now we have this button that takes up a significant amount of space, and it's a lot more clean that way. Alright, so thirsty. I'm going to get myself a drink after this. Tim Hortons. Okay. So, in terms of UI, what we actually want to do right now is set up padding. Now, padding is kind of annoying sometimes, but for now it's going to be fine to work with. What I'm going to do is I'm going to set a padding of 15 units on the game instructions. Actually, we'll do 30 units. And that gives us a lot of space between the title and the button. That's good. I'm also going to set the game instructions and the title pad or text align to be centered. Okay. And now we have a pretty good start screen. So let's set the text of everything. So the title is going to be Welcome to Pong. And the game instructions is going to be your goal is to keep the ball from getting past your paddle while trying to get it past the other player's paddle. If you get the ball past the paddle, or past the opponent's paddle, you get a point. If the opponent gets the ball past you, they get a point. The first player to get 30 points wins. Use the mouse to move your paddle up and down to hit the ball. Okay. It is definitely a little bugged out, but God. Why did it bug out? I'm not even going to attempt to fix that bug. That is... I'm just gonna work around it. That is a lot of user interface layout code that I do not feel like writing right now. I do not like doing UI layout code. So what I'm going to do to work around that is I'm going to actually, instead of setting the padding on the game instructions, I'm going to set it on the title and the button itself. And it's still smashed. That's great. Love you, Thundershock. Alright, instead of 480 units, let's do 640. Nope, it's still very... So I'm going to do another little improvisation here and set the button padding to 60. I don't know why that's happening, but it is. Yeah, it is what it is. Okay. So for some reason that ended up giving me 30 unit padding on the button now, and yeah, that's Thundershock for you. That's what happens when a college student writes their own game engine in 3 months and doesn't have any other person to actually help fix the engine. You get bugs like that. Anyway, occasionally you will have to work around bugs like that, and that's the reality of things. Can only do so much. Writing a UI system is hard, okay? Anyway, what we're going to do now is we're going to set the text of the start button to Let's Play. Actually, no, we're going to reference Windows 8 and do Let's Start. And to make the start button actually work, also, I realized something that we forgot to do. Paused needs to be set to true. So what we're going to do is we're going to bind an event to the start button's mouse up event. And we're going to say, okay, if the mouse is the primary mouse button, then we are going to go ahead and say that the start panel visibility is collapsed. And then we're going to say that counting down, which is a variable we're about to create, is true, and that the countdown visibility, or countdown GUI.visibility is visibility.visible, and countdown is 3. Let's define those variables. So under game state, we're going to define a counting down boolean. It's going to be default to false. We're going to define a countdown double, which is going to be 0, and that's going to be the amount of time left until the countdown is over. And then for the UI, we're going to set up some countdown information. So the first thing that we're going to have is a stacker. And then we're going to have some text. And then below, or on the viewport, I'm going to add the stacker, and I'm going to center it. And I'm going to add it below the main game panel. And the way we do that is we just do the viewport add call for the start screen. So let me see where it is. It's going to be GUI right here. So if I want to add the countdown battle before, I just literally add it before. I don't know why I explained that. So countdown GUI, and then countdown GUI.shelburne.add, countdown title, and countdown text. great. And then countdown title text align equals text align dot center. Same for countdown text. If I could type the word countdown, that would be great. Alright, let's try this again. Countdown. Oops. Oh my god, I can't type today. There we go. And I'm dumb. You can't display text with a stacker. It's... Oh my god. I'm dumb. I'm so freaking dumb. Anyway. Now that should be fixed. It should now be properly setting the countdown timer. Okay, so let's actually set up the countdown text right now, first and foremost. So we're not going to worry about the game being paused. If we are counting down, we're going to say, okay, if countdown is less than or equal to 0, then we are no longer counting down. Oh, and by the way, countdown GUI visible, or visibility equals counting down, and this is where my mentor would freaking tear me apart right now because I'm using a ternary operator, and come on, ternary operators are amazing. I don't care what anyone says, they are amazing. They are gods. They are... I don't even have words to explain how amazing these operators are. I'm sorry. Anyway, visibility.visible if counting down is true, otherwise collapsed. And then what I'm going to do is I'm going to say countdown text text equals math.round countdown .toString. And then I'm going to say countdown is minus equal to game time elapsed time total seconds. Also, if counting down is becoming false, then obviously pause is going to become false as well. And then what we can do is when we start the game, we can just say that we are counting down, and we don't have to worry about the GUI being visible. We don't need to worry about any of that. All we have to do is say that the countdown title text, as I get hiccups for being thirsty, is ready to play. And let's test that out. So we hit the start playing, or let's start button. And, I mean, it didn't display the UI great. That's great. But it did do a little bit of a countdown there, and I will probably skin this to be a lot better looking in terms of UI, but one thing we can do is just add a boatload of padding to both the countdown title and the countdown text. So let's see here. countdown title, padding equals 200. Oh yeah, I forgot, we have to set the text color. I'm dumb. Oh, see, now PetBrains learns that I want to use my own color structure. I see Tobias is back. Awesome. Anyway, now we have a countdown. Don't ask me where the actual number is, but it did work. Anyway, the next thing that we're going to do is, of course, get the countdown working for when we lose or win the game. Or rather, when the ball... when the ball gets past a particular paddle. So in this case, what we're going to do is... no, this is for when the ball hits a paddle. I want for when the ball goes beyond a paddle. So this is for the CPU is beacon. So in here we're going to say counting down equals true, and countdown equals 3, and countdown you got a point for the title. There we go. And then we're going to do the same thing for the player being beat. And instead of you getting a point, I'm going to say CPU got or gets a point. So now we have a start screen, have a countdown screen. And we have a countdown screen for when the player wins and for when the player loses. Now, the last thing that we're going to add is going to be the score text. As you can see, there it goes saying that I get a point. Oh wait, it should have paused the game. I'm dumb. Let's fix that. And it also said that the CPU got a point, not me getting a point, anyway. So that's fixed. The last thing that we're going to add is the 2 text blocks for the player and the CPU score, and that's relatively easy to do. So under a new section, we're going to add 2 text blocks. Score texts, and we're going to do private text block player score text and CPU score text. Okay, and then we're going to add these below, or on the user interface viewport below the countdown panel, or countdown stacker. GUI.add to viewport, player score text, GUI.add to viewport, CPU score text. Now, next thing that we need to do is actually position them on screen. Now, Thundershock has 2 ways of doing viewport level positioning. First way is the advanced way. And that's what we've been doing for the stack panel and for the start screen and the countdown panel. And that is creating some sort of layout control to put all of your content controls in and let the layout control dictate how the content is laid out. That's what stack panels do, that's what wrap panels do, that's what item panels do, that's what canvas panels do, and that's what scroll panels do. They are layout elements and they define the layout of the content, which in this case would be a button, text, etc. The other way you can do layout in Thundershock's GUI system is at a port level only, and is the basic layout, which is similar to Windows Forms, the fact that you can actually anchor things and position things and stuff like that in a free-form style. And that's good for HUD elements, where they're mostly going to stay in the same spot, and they don't need to really react to the screen layout or anything like that. That's what we're going to be using for our score elements. We're going to use the basic layout system. So let's do that. The way it works is we're going to go ahead and set their origin points to be their center, or to be the center of their elements. So the way we do that is we do player score text dot viewport alignment equals new vector 2 0.5 and 0.5, 1/2, 1/2. And that's going to set the origin point of the element to be its center position. We do the same thing for CPU. Then we need to anchor them somehow. We need to position them. Anchoring is the best way to position these. See, what we're going to do is, by default, the anchor is set to the full screen. So that's a top left value of 0, 0 and a bottom right value of 1, 1. If we set the bottom right value to 0, 0, then that means that there's no actual stretching going on, and we can then use the anchor as a way to position things. Likewise, if we set the anchor position to, or the anchor top left value to something like 0.5, it's going to center it in the middle of the screen. If we set it to 0.25, it'll use the first quarter of the screen, and so on. So let's see how that all works. So what I'm going to do is I'm going to use 0.1 as my top anchor position. I'm going to use a quarter of the screen for the X position, which is something to explain when I'm taking into account both the text blocks. But I have it in my head what this is going to look like. So we're going to start with the player. We're going to get it positioned properly. So to do that, generally the score is going to be on your half of the screen. So player score text viewport anchor is going to be a new free panel canvas anchor, and this is what I mean. So we have 4 values that we need to set. We have a top, we have a left, we have a bottom, and a right. Let's get that screen back. So we have a left top, bottom, or left top, right bottom. Consider the left and the top to be the location of the top left coordinate of the element. So 0, 0 means that it's in the top left portion of the screen, and 1, 1 meaning it's in the bottom right. And consider the bottom and right values to be where it's going to put the bottom right or bottom right corner of the element. So 1, 1 means that it's going to stretch it to the bottom right of the screen. In this case, we don't want stretching, so we're going to set those to 0, 0. So if left and top is the position of the top and left of the UI element, and setting right and bottom to 0 means that we're not going to actually influence the bottom right corner, then left and top suddenly become position value. That's kind of hard to explain. I know. If you're confused, I don't blame you. It is very confusing, but you'll see what this means. So basically, for the player, if we want it to be in the left quarter of the screen, in the center of that quarter, we're going to set the left value to 0.25. 1 quarter. And I'm going to set the top value to 0.1f, just because that's a tenth of the screen in the Y position. And I'm going to set the bottom and the right to be 0. Okay. What is my IDE? Okay. What we are going to notice when we start the game is we should see a text block roughly... no we don't. I don't. Oh yes, the colors. That's gonna keep tripping me up. Don't use system.drawing, don't use system.drawing, don't use... There we go. Okay. Also do the same for CPU. I forgot about the colors, but once we get that sorted out... Oh, whoops. So as you can see, there's now text there. Now I might actually set it to 0.05 on the Y value, but you can see what it did there. The basic layout system is allowing us to arbitrarily position a Y element on screen, which is important for a heads-up display, like this. Now, if we would like to set the CPU to be on its side of the screen, it's the same idea, just we replace the 0.25 on the left with a 0.75 on the left to denote 3/4. So let's do that. So let's replace a little 2 with a little 5, or with a little 7, and then we take my... I think my laptop is bored at the amount of activity in the chat. And I see Tobias is now going to sleep. Right. We're almost done the stream here. We have the score text mostly set up. Now I'm not going to do the win or the lose screen just yet. I'm going to do that later on on my own, just because this is getting long and we're basically done, and it's pretty not trivial to set those screens up. Well, it is trivial. It's just time consuming because it's user interface work. I don't like UI work. Really don't like UI work, even if it's in my own game engine. Anyway, the last thing that we need to do to make this work is to set the score text to be the score. So let's do that. So player score text dot text equals player score dot toString, and then CPU score text dot text equals CPU score dot toString. We have created Pong. This is Pong in Thundershock. So, what have we done? We have set up a start screen, which is great. We've set up a movable ball that's controlled by some sort of speed value, and we can influence that speed value, and we're not actually controlling how the ball renders, just where it is on screen. In the ECS that's inside Thundershock to let it render. We've set up a player paddle that is movable by the mouse, and we've set up a basic Pong AI to move the view panel. Then on top of that, what we have done is we've created a basic scoring system whereby if the ball gets past the CPU, then the player gets the point. And if the ball gets past the player like it's about to, the CPU gets the point. And then we get a countdown screen. We've learned how to use both the advanced layout system and the basic layout system inside Thundershock to get what we needed to do done. And we've also learned how to transform coordinates from world space to view space to screen space and back. I wanted to do audio, but audio is a bit complicated and annoying to do, and I will do that likely in another stream, where I show you guys how to do music and how to do audio. But yeah, this is a game inside Thundershock, and in fact, there's even a little bit of bloom on the ball. You notice that? Boom. Close. There's the CRT Shadow Mask effect. So this is like the most retro-looking Pong in a modern game engine that you will have ever seen. Probably. There's probably more of a retro-looking Pong out there. Anyway, that's gonna do it. That's the live stream. Now, of course, Pong, this isn't impressive. This is not a very impressive game. This is one of the easiest games that I have ever worked on in my life. The hard part of this is the game engine itself. If you want to see something impressive that I'm working on, and that, okay, if you want to see something impressive that I'm working on, I would look into Socially Distant. But if you want to see something really oh my god, what the hell is happening? If you want to see something really impressive, I want you to check out the link in the video description below. The website is very much not mine, that I am on the team for. That would be, well, I mentioned it in the beginning of the stream, or in the beginning of the stream. I have had the great opportunity. My voice is messing with me now. I really need to drink something. But I have had the great opportunity to join Trixel Creative to work on Restitched. So this in front of you right now is how to use my game engine to build something simple. If you want to see something impressive, go ahead and go over to Restitched and see what's going on there. With that said, I am really excited to keep doing these live streams. I don't know if they're going to be weekly, but I'm going to try. I'm not going to make any promises. I'm also going to make sure that this doesn't happen, because this is very clearly a bug. I think I messed up some code somewhere in this along the way, but oh well, I will fix it. You can see that the AI is just having trouble. Anyway, that's gonna do it for the live stream. The last thing that I will say is, of course, that I will be making a community forum, and I will set that up, and yes, it will be using Discourse. Tobias, I know you're asleep now. I asked that question earlier, and I'm going to answer it now. It will be Discourse. And I will let you guys know once the forum is ready to go in another video. And with that said, I've been Michael, always. Hope you learned something. Hope you enjoyed the stream. Hope to see you guys both in the Restitched Discord, or Trixel Discord, and my own Discord. Links in the description. I will see you guys in the next one. Thanks for watching. By the way, I will also have this Pong repository on GitHub pretty soon. Anyway, I'm gonna exit out of the game. We're gonna end the stream, and I'll see you guys in the next one. Thanks for watching.